So today I'm going to show you guys a different method of machining rotors. So by now I should have shown you the off-car or our bench lathe. Now I'm going to talk about what's called an on-car lathe. And here's the reason why it's super important, and a lot of manufacturers are actually making this their preferred method of how to machine rotors. So even if we have a perfectly flat rotor, the problem is behind the rotor you have what's called a hub. So this is the part of the drivetrain that mounts the rotor onto this, and then your tire would go here. If this hub, this spinning portion of the vehicle, if this hub is not perfectly straight, even if we have a perfectly flat rotor, we could get some vibration by this hub right here. So what an on-car brake lathe does is it takes into account any kind of vibration or any kind of warpage from the rotor or the hub, and it machines it all into a perfectly flat surface. So here's our on-car brake lathe. It's made by the same company as our off-car brake lathe, ProCut. And again, this is definitely becoming industry standard. So what this ultimately is going to do is we are going to mount this flange onto the vehicle. There is a motor inside of here that is going to drive and spin the rotor. And then much like our off-car brake lathe, we have a cutting head. So the cutting head has a couple of bits on the end of it, and we are going to machine and take a small portion of the rotor off, leaving us with a perfectly flat surface. So this comes on a rolling cart, so you can roll this right up to your workstation. On the bottom of the cart, there are some adapters that I'm going to show you in just a minute as I am working on our Subaru today. So let's go ahead and get the car set up and ready to machine the rotors on the vehicle. Let's go ahead and get the vehicle set up to machine the rotors on the car. And the nice thing about doing the service on the car is there's very minimal steps in order to get the vehicle ready. So there is a caliper, and we're going to have to take the caliper off. But attached to the caliper and what actually holds it in place is a mounting bracket. If I was to take the rotor all the way off and do this on my off-car lathe, I would have to remove this bracket as well. To do it on the car, I actually don't have to take this off. So let's go ahead and remove the caliper and get the vehicle set up. Just a reminder, never hang your caliper by the brake line. You're going to stress that brake line out, prematurely wear it out. So we're going to use an S-hook today. This comes with the on-car lathe. You can also use a coat hanger or anything that you can fasten to hang the caliper by. Now we're going to remove the brake pads. So now we're ready to actually machine the rotor, and we're going to now install the tool. But first, we need to figure out an adapter. So the machine comes with a couple of different adapters, and what we need to figure out is the stud pattern. We need to match that up with its proper adapter. So on ProCut's website, you can actually look it up and it'll tell you which adapter to use. For our Subaru, we are going to be using 50-688. We're going to go ahead and install. Now I'm going to wheel the machine over, and then I'm actually going to install it. So again, we are going to put the flange of the machine onto our adapter, making sure that the cutting head, I don't hit the rotor, and then I also don't want it to hit the vehicle. So I'm going to move this out just a little bit. Now I'm going to plug in the machine and let it power up. So it does a quick warm-up process. Now we are ready. So we can turn the machine on. This is going to actually start spinning the rotor. There we go. The machine's it's gonna be moving a little bit. So what this machine is actually gonna do is it's gonna measure the actual run out or wobble that the setup has, and it's going to compensate for it. So again, if this rotor and hub setup has a lot of movement, the machine is actually able to determine that, and then we are going to cut the rotor essentially to the car. So it's going to be perfectly square and zeroed up and flat to this portion of the vehicle. So we hit start, and then it's going to go ahead and make some clicking noises and do some adjustments, and then it's going to ultimately tell us when it's ready to cut. As you can see, we have a double green light. My number is below 1/1000th of an inch. It's called run out. So we are ready to cut. Next, we need to adjust the cutting head, and we have a couple of different levers. We have the yellow lever on top. This one actually allows us to adjust the cutting head in and out. And then we have this black thumb screw right here. This is what locks in my cutting head depth. So we're going to loosen this up. We're going to center up the cutting head. Yep. And we're going to loosen this, and we're going to open up the bits to make sure that we don't contact the bits onto the rotor as I turn in. And then just below, I'll back you guys up. Sorry about that. Now we have this wheel, and this is what engages my cutting head in or out. So we're going to run it in just like we did on the off-car brake lathe to about the middle of the rotor. Take about the middle. So we still have this lever locked. Now I'm going to loosen the thumb wheel, and on the inside edge, because I can't visually see it, I can only hear when the bit touches. I'm going to slowly engage until I hear the bit touch. There we go. So there's my scratch cut. Now I'm going to do the same thing on the outside. I'm going to move you guys in just a little bit closer. This one you're going to actually be able to visually see when I make the scratch cut. Now I'm going to move the cutting head all the way into the center. Again, making sure not to contact the cutting head onto any portion of the rotor or the caliper, anything. There we go. All right, so now we're going to go back to zero where I know that my scratch cut was made. And then I'm going to take, I will do about, each of these lines is 0.0025 or 25 10,000ths. We'll think of it as 2,000ths. So 2 lines, that's 5,000ths of an inch. I'm going to go about 3 lines. So we're going to go 1, 2, and 3. 1, 2, and 3. We're going to lock this down. And then I almost forgot to install my chip deflector. So I can actually rotate the machine up and down, so I had to move it just a little bit down to fit my chip deflector in. Now we'll go ahead and make the cut. All right, it actually took a couple of passes because I had some pretty deep scores on the rotor. But as you can see, it took about 4 passes, which is a little bit unusual. So this one I would further inspect to determine why I had some deep scores. But now my rotor is nice and flat and smooth. Let's go ahead and remove the machine. I'm going to blow and get rid of all the particles that are left over. I want to give the rotor a nice clean because don't forget, it is now dirty. Right, all that leftover metal is there's still some of it on here. So I want to give this a nice clean, and then we're going to reassemble the caliper. And there we go. We have a completed job, and now I would machine the other side.